presentation is about the baseline generation tool. My name is Edgar Segovia. This tool was developed for eDream project. And this presentation has 4 sections. The first section is about the importance of the baseline. The second section is about input for the tool, processing data, and output. That are the 4 sections. All right, with the first section. And the question is, why are the baseline important? And basically, there are 3 areas that we can, or 3 reasons because we can say that the baseline are important. The first reason is the business opportunities. The baseline open a new business opportunity for energy market or flexibility energy market. The second area is technology impact. Thanks of the baselines, we can develop or integrate new technologies to the grid. For example, the renewable energies. Now, one of the problems with the renewable energies is we cannot match the generation with the consumption. And maybe with the baseline, we can try to match them and we can improve the use of renewable energies. And the last one, but not for that reason less important, is environmental impact. All right, the baseline cannot impact or have not a direct impact of the environment, but thanks of the use of new technologies like storage technology or renewable energies, we can have a positive impact in the environment. All right, now I will go with the second section of the presentation. It's about input for the tool. We'll have 3 inputs: the date, then the tool generates a baseline for that date that the user can select, the historical consumption, and the weather data. The historical consumption and the weather data come in a CSV file format. Here you can see an example of the historical consumption. In any line, there is a date. In that case, in the first line, we can see the year, the month, the day, and then the time and the kilowatt consumption. That is for any half hours step. So there are 48 steps for one day. Now I will go with this next section, the processing data. The processing data used is forecasting algorithms, and all that algorithms are described in the deliverable 3.2 that is already published. And the deliverable 3.6 will be published at the end of the project and going deep with all the algorithms and methodology used for generate the baselines. Methodology used in or studied in that project are comparable day, x of y, recursive and square, additional adjustment, multiplication adjustment, and weather adjustment. All right, now I will go with the last part of the presentation. It's about output. The output come in a CSV format like the input, but this time is generated for one day and also in a step of half hour. So in that case, we can see here 6480, that is the kilowatt consumption for the step as half hour steps for one day. And here you can see one video about how work the tool. Here, for example, the user can introduce the day, then the location for the CSV file, then the user can pick which or can select which methodology you want to use. And at the end, the tool generates the baseline for one day, so 48 predictions for any half hour of consumption. In this project, we develop another tool, this time in MATLAB, and this tool can generate baseline for all the buildings. In that case, you can select for all the buildings or for just one, and you can select period of time bigger than 1 day. And in this case, generate baselines with all the methodologies. For that reason, take more time. In that case, you will see the lamp go to red when it's ready. That's take around 15 minutes or half hour, because make the same process, but for any baseline for all the buildings at the same time. In this case, that tool was used for compare the different baselines. And we can see here the different baselines for 2 different buildings in England. Well, at the left for the building number 6 and at the right for the building number 21. In both cases, the first one at the top is the consumption, real consumption, and then we have the different baselines for different methodologies. In this project, we compare that different methodologies, and in order to say which methodology is better than other ones. And in the case of UK, we have here the error for medium error for all the buildings. And we can see in green which are the best options for generate a baseline. In that case are the multiplication and addition adjustment for x of y high and middle baseline. We can see here in September, for example, we have the error that 12%, and here for October we have an error of 6%. So if we keep we select one of these methodologies, we can say that the error will be lower than with other methodologies. That table is for the Italian case, and in that cases we have the information for 3 years. So we compare different years and we calculate the error for all the buildings during this period of time. And we can see that the multiplication adjustment and the additional adjustment with 20, 35, and 35%. And in that case, the minimum error was in 9, 8, and 6 buildings. So if we select one of that methodologies, we can say that the error will be lower than with other methodologies. In that case, it's important to say that the worst methodology was the normal simple regression, and maybe it's not a good idea to use it.